Today we are going to discuss nomenclature of complex compound. So some rules are taken into consideration while doing the nomenclature of complex compounds. Like we have an example. If this is written on the left side, then this is cation. I have written this here. And it is always named as its original name, like potassium. But if there is a compound or something else or single atom on the right side, then it is anion. And for this, if this is like a sulfate molecule, then we will write a sulfate here. And if this is a single atom, then we will write IDE, chloride. In this case, it is chloride. And for this, we're just going to name the ligands according to the ligands rule. And for here, we will use this Latin name and add 8 as suffix. So let's name the first compound. We have a compound K4FeCN6. So this is written on the left side. This is a cation. So named as potassium. And now we will name ligands first. Ligand contains 6. So hexa. This ligand is named as cyano. And then for iron, its Latin name is ferrous. So we will name as ferrate. And now calculate its oxidation. Okay, so we will write its oxidation. If this is +4, then this whole will be -4 is equal to -4 Fe. We have to find the oxidation state of iron, and for cyano 6 and -1. X minus 6 is equal to -4. X is equal to -4 plus 6. X is equal to 2. So we will write it in Roman numeral 2. So the first compound has been named. So now move on the second compound. K3FeCN6. Again, this is a cation, potassium. Hexa, cyano, ferrate. And now calculate the oxidation state. If this is +3, means 3 into +1. For potassium, oxidation state is +1. Then this whole compound is -3 is equal to -3 Fe. We have to calculate for Fe. X plus 6 into, for cyano, the oxidation state is -1. So X is equal to 3. Just write 3 over here. So the name of this compound is potassium hexacyanoferrate 3 ion. It is your will whether you write ion here or not. Now for the next compound, NaMnCO5. Again, sodium is used as a cation, so it will named as sodium, not natrium. We're not going to use its Latin name. Sodium, penta, for 5 penta. This is carbonyl. You don't have to put a gap over here. I just put it for the convenience. Penta carbonyl manganate. Now calculate the oxidation for sodium +1 and this whole compound is -1. So put -1 over here. X plus 5 for carbonyl compound. The oxidation state is 0. X is equal to -1. So just write 1 over here. Sodium pentacarbonyl manganate 1. Now for next example, Na2 NiCN4. Again this is on the left side and will be named as cation. Sodium, then ligand. 4 for tetra, Cn for cyano, and nickel 8. Nickel 8. Now calculate the oxidation state if this is sodium +1 and 2 compounds. 2 into +1 plus 2, then this whole compound is -2. -2 is equal to nickel X plus 4 into -1. 4 into -1 for cyano. This gives us X minus 4 is equal to -2. X is equal to -2 plus 4. This gives us 2. So this is named as sodium tetracyanonickelate 2. Now for the next compound, PTNH3 twice Cl4. Outside the bracket there is neither a cation nor an anion. Okay, nothing is written over here and nothing over here, so just ignore it. Named it according to the ligands. Make sure that the ligands are arranged in alphabetical order. Okay, for ammonia we use amine with the double M, not with the single M. So just write for 2-diamine, we write double M in amine, not single L, not single M. Diamine tetrachloro A comes before C, so this is already alphabetically arranged. Platinate. Now calculate the oxidation state. We will write for platinum X plus 2, ammonia is a neutral molecule, so 0 plus 4 into -1. This gives us X plus 0 whole is equal to 0 minus 4. X is equal to 4. So this is not choose as a 9. I mean it is not on the right side, it is on the left, so we will not choose here platinate but platinum 4. Diamine tetrachloro platinum 4. Now another example like this, zinc Cl4 whole -2. Here we are given -2. Okay, first calculate the oxidation state. For zinc just put X, and 4 for chloride, -1 is equal to -2. X minus 4 is equal to -2. This goes there in addition form. This gives us 2. Okay, this means this is a neutral compound or has a positive oxidation state. So let's name it, and -2 shows this whole is an anion. So we will add 8 at the end. 4 tetrachlorosincate, and just write its oxidation state in numeral, and that is 2. Another compound, Ag NH3 twice. Wait for a minute. Kg NH3 twice Cl. So we have this one compound. Now outside the bracket we have the one on the right. So this will act as an anion, and this will act as a cation. The one on the left is cation and on the right is anion. Okay. Now first calculate the oxidation state. Chloride ion has a -1 oxidation state. So this whole has +1 oxidation state. Now let's discuss for silver. We have to find for silver. So just write X plus 2. For amine, it is a molecule, so it will be written as 0 is equal to +1. X is equal to +1. Okay, so the silver has +1. Now write the name of the compound. Diamine. Never forget that the amine will be double M. Diamine silver. Why we don't choose its Latin name argentum? Because it is in positive oxidation state. The whole compound is positive. We don't consider whether it is positive or negative, but we consider the main written in the bracket whether it is positive or negative. It is positive, so silver and then chloride. Now write the oxidation state of silver, that is 1. So the name has been written.